Okay, so I'll talk a little bit, Sharon, just of some of the kind of principles in heating building, but then I'll get into some inventions that have been invented in the interior and some stuff that's kind of off the shelf that helps with heating, whether it's space, whether it's water, or heating food. Um, so I'll go ahead at this point and let me know if the presentation that I'm about to show is appearing. Um, let's see here if it is appearing on your window. And I'm going to just need to change modes in my PowerPoint very quickly. Let's see. So let me just do this and I will be right with you. Okay, and then if I extend this, okay, there, I believe that I am ready to go ahead, and you can let me know how small or how large it is. So right now, we'll choose this one. Do you see a slide with a log cabin on it?
Yes.
Yes.
Okay, and is it large enough to see? It's just a little icon in the corner of my screen.
I can see it just fine. And
Okay.
then I can
Oh,
see you at the top, which is great.
sure, sure. And if you need to do some work around there, feel free. I'm going to just kind of power through the PowerPoint, and at any time, I'll stop every 5 or 10 slides and just ask if you got any questions and such.
And Artie, if you want to make the that screen larger, I think you can do that. I'm just looking
Okay.
if there's a swap mode on the button there. Let me see. I think there is
Okay.
one. So I'm going to share something just for a second, and then
Sure.
that way I can see where my sharing button. Oh, okay, I got overrode. Down at the bottom,
Yeah.
do you see the buttons? What if you hover over them? Do you have a different one, or can you click on the presentation in the corner? I want it to be big enough where you can use it.
Oh, okay. Well, yeah. So I have a button that has a picture of a person, and
Mm-hmm.
then so that's hide self view. There's turn camera off, turn microphone off, adjust volume, go full screen mode, and share presentation and end.
Oh, you know, I think there's a way to do it. I just don't know what it is. But can you see
That's
what you
okay.
need to see?
Yeah, I can. I've got
Okay.
the PowerPoint in front of me, and so I'll just advance it on through.
Okay, so if you go ahead and just announce the topic again, we'll just start the actual recording part from here.
Oh,
So we'll
yeah,
crop it to
sure.
this, and that way it'll have everything.
This is Art Nash with UAF Cooperative Extension Energy Specialist, and today, March 4th of 2014, I'll be going over the topic for our brown bag lunch, heating remote cabins. Typically, these presentations run 1 hour. However, we'll be going 45 minutes on this one as we did wait for some attendees who thought that they might be able to make it who weren't able to. I can always be contacted at my phone of 474-6366 here in Fairbanks, or my email, alnashjr@alaska.edu. It reads Al Nash Jr. If you want a copy of the presentation, I can also supply that. The first slide that I have up today shows a cabin, a typical Alaskan interior cabin. You'll notice that the windows are kind of low. The roof line certainly doesn't start at 8 foot. It's probably more like 6 foot and such. But what's most important is in the foreground, you'll see that there's some drums, maybe used for different types of vehicle fuel and such. And right before that is a saw jack. You have kind of a stand of two ends and then a long V-shaped trough, if you would, and that's to hold wood. Now, we don't see a smokestack out of this cabin, but it would be hard to fathom unless there's a Toyo stove that directly vents out of the back side that we can't see, and possibly that's what the oil drums are for. it's hard to fathom that this house isn't heated by wood. Now, many of the old cabins like this, the way that they heated with wood was they would take a drum, such as you can see in the lower right-hand corner. They would go ahead and lay it flat, cut a hole about 8 inches in the top of it, and stab through a stovepipe. Of course, they go through the roof the same, and then they put it on a small stand to keep it about a foot off the ground, or maybe 2 feet off the ground. And then on the end, where the drum lid would normally go, they cut a square and put a little hinged gate in there, and voila, out of a 55-gallon drum, you would have a drum stove. Not a very efficient burner by any means because of the very thin plating of the drum, and because of the fact that probably half of the BTUs, that's British thermal units, how we measure energy, heat energy, would be going up the smokestack with the wood smoke. There's no really recovery way of retrieving the smoke, bringing it back down into the fire and burning a lot of those volatile gases that hold BTUs back into the burn. But for much of rural Alaska, even through the 2000s with some of elders' cabins and such like that up on the Yukon, this is how people typically heated their cabins. One disadvantage, as you can imagine, especially with a cabin this size of what you see in front of you, is that the part of the room, the corner of the room that had the stove, was the corner that would heat up. So you'd get an uneven heating of the air in the room unless you had some type of fan or way of moving it around, or the cabin rather. And the more rooms you have, of course, that creates obstacles. The other, I guess you'd say, disadvantage is that without any type of ventilation or heat flow, the heat would kind of pocket maybe the intense heat in one corner of the cabin, and at 40 below, that has a whole different dynamic on the wooden logs that are close to it, and you might have on the other corner of the cabin wooden logs that on the inside even have a little bit of frost. So you have a different drying aspect of your actual building materials instead of a uniform type of heat. When we heat a house, we not only heat our bodies, but indeed we're also, or a cabin, we're also heating, of course, all the building materials throughout the place. Last night in a workshop, I was asked about those roofs and walls that are made instead of with logs such as this, that are made with 2x4 or 2x6 studs, and then have insulation in between those studs and have a plaster board or a drywall on the inside. People mentioned that they often saw shadows or ghosts every 16 inches, that they could predict where the next stud was going to be because it was just a dark line, the same thickness, 1.5 inch for a 2x4 or 2x6 every 16 inches. And that's because in that case, the studs are acting like a heat bridge to transfer heat from the inside of the house out to the cold on the other end. And unfortunately, when a house isn't well insulated, the walls, or if it's in a roof, you have a cold roof, it just shows that certain parts of the house are accepting heat and others aren't. This can cause problem in time if there's condensation, especially in the walls with this uneven heat. So without further ado, that's kind of again, an interior cabin that would be typical. Yours, though, might be built with studs. And we'll be talking about some type of heating units today for water, food, or for space heat that, for the most part, it doesn't matter whether you've got horizontal logs or vertical studs. So much of Alaska, of course, is what we would call remote. In other words, from an electricity point of view, much of the state is without a continuous grid. If you look at this map, the part that has the dotted line from Seward, all the way up to Prudhoe Bay. Well, that's our road system. And you'll see it also goes down to Valdez. And then, of course, it goes out to Tok and such. But aside from the black lines, you really don't have a continual grid. You'll see over in Nome that there's some lines. And I should add that the part that's dotted is known as the rail belt, And communities along that rail belt of that dotted line are going to have a continuous grid of electricity. But for your cabin, you may be living right in, let's say, Anchorage, but you might go 50 miles out to your cabin. You might hike in, you might boat in over at Squetna maybe, and there just is not the ability to plug into electrical lines, so to speak. Now, in much of Alaska, people, at least rural Alaska, people tend to heat their space heat with fuel oil. And fuel oil is good because it's a very compact way of holding BTUs, British thermal units of energy. The problem with fuel oil is that its strength, the fact that it's liquid so that you don't need to feed a fire, but it naturally flows, can also be a detriment if you need to get it out into rural areas where you're hauling it by snow machine, plane, or four-wheeler. It's very cumbersome to haul a 55-gallon drum because of the sloshing around of the liquid and such if you're going over rough terrain. Some people do haul in drums into their cabins where they can. There's always the risk of spilling, and believe it or not, even number one diesel oil is considered as a quote-unquote hazardous waste. So if there is a spill, usually out in the rural areas, you're not going to have anybody tracking you down, trying to figure out how you're going to clean it up and such. But there are other types of fuels that we can haul out that maybe aren't so cumbersome. So before we get into actual devices and talk about actual fuels, I just want to talk about something that's just as true for a cabin as it is for a home. And that is this dance, so to speak, that we try to do with energy efficiency. That is keeping as much heat in the house as possible, having good airflow, that is ventilation to get stale, exhausted air out of the cabin with fresh air coming in, and moisture. We have a situation, at least in the interior of Alaska, where the air is very, very dry. Now, there's a few dynamics that I just want to brush over, and that is about air, and that is that the colder air is, the less capacity it has to hold moisture. And so in a 40 below situation, you have an extremely dry humidity, very low percentage. And so in your house, if you're bathing or showering, or if you're in a cabin situation off grid, where still you're producing some moisture by cooking and even breathing, believe it or not, the air in your cabin, which is warmer, can contain more of that moisture and can hold it and hang on to it more or less. And that actually is a good thing. It's suggested that generally the optimal spot for our respiratory health and for fighting off viruses and bacteria and everything else, the optimal spot of air moisture humidity is right around 50%, anywhere from 40 to 60%. So we actually would like to have it fairly moist inside. However, when we try to move air outside, that moisture is going to go with it, and often also our energy, the BTUs in the air, is going to go right out also. So there's a device that we often have in our homes, a heated recovery ventilation system, that basically tries to bring in fresh, cold, dry air. And within that box that looks like a diamond, it crosses over, the fresh air crosses over with stale used moist air in your home, and it transfers in that box both moisture and heat so that the outgoing air is cooler and you can take some of the staleness out, and the incoming air, even though it comes in dry and cold, can hold some of that moisture and keep the heat, so to speak. The problem with the heated recovery ventilation system is that it's designed with some fairly sophisticated controls that require regular 110 outlet type of electricity on a continual basis. And what often happens then is that the electricity, if you're on a generator, needs to run constant. And with generators, we have brownouts. There are times where we turn a generator off because we don't want to waste the fuel and such. The other problem with an HRV system, or not problem, but I guess design consideration, is that HRV systems are designed to then have ducts go to different parts of the house, into different rooms and such. And so it's a bit overkill for a cabin that doesn't have 2 bedrooms that are sequestered off by doors, maybe bathrooms and other rooms of the house, dens and stuff that you would normally shut off. So instead, a device that's very reasonably priced and takes no electricity, made in Sweden, is called a Fresh 80 or a Fresh 100. You cut a hole in the wall about 4 inches, 3 or 4 inches depending on which one you get, and the Fresh 100 just is able to handle more. And you basically slide this tube through so that the end, which is to your upper left-hand corner, goes to the outside wall, wall portion of the cabin. And it has a little vent on there to keep the bees out and a little screen on. And then on the inside portion, you kind of cap it off with that mushroom-looking head and that square plastic piece. Slip that on the inside of the wall, so that the tube is basically going through your wall. And the idea is that by pulling on that drawstring, you allow fresh air to come into the house, because that drawstring activates that spring-loaded mushroom-looking head, and it allows a small crack that you can see to the left of it for fresh air to come in. That tube is big enough and long enough that it acts without electricity, sort of like a heat exchanger or a heated recovery ventilation system, so that when the cold air comes in, it mixes in that tube with the warm air going out. So again, and just to reiterate, till we look at right before here, looking at different types of equipment as well as fuels, just keep in mind that the more that you vent for fresh air in your home, probably the more energy you're going to lose. And with that, and it being heat of the ambient air, with that you also probably will lose a good amount of the moisture also. So I wanted to mention that just because for respiratory health and comfort, that is something to consider. Now, when you go to a remote area like your cabin, you have to ask yourself, well, which fuels am I going to use and why? What am I using it for? And you might take up some white gas, like for a little Coleman stove, to go ahead and heat up food. You might again bring up diesel oil. You might also bring up cylinders of propane that are fairly easy to strap down, and when they're in the sled behind a snow machine or on the back of a four-wheeler, you certainly don't want to drop them and ding the valve. That can make it into a real nice missile, believe it or not, depending on what kind of pressurization you have on that thing. But at least it doesn't slosh around and such and affect your vehicle. back and forth on the trail. But you want to determine, you might be able to use some of the driftwood if you're down by the coast, or even in Kenai peninsula area, you might be able to use some of the coal that comes up. I was at one of the state fairs in Nikiski, and somebody brought me big chunks of coal. I said, where'd that come from? They said, well, it's just kind of right there on the beach. Or you may go ahead and cut cordwood. Now, what will you use it for? Well, people in cabins obviously do cooking, and sometimes they'll prepare fish if it's at fish camp. They also might decide to try to do some laundry with an old washboard and need some warm water. And then what efficiency actions can you take to reduce the need of your heat? Well, you can be sure to do some of the same things that you do at your home. You can put up rubber threshold around the door, and then maybe even a blanket over that to try to keep a lot of infiltration of air. A lot of people in cabins use small windows compared to their home windows, because a window does transfer heat through the glass, even if you have a buffer zone in a dual pane or a tri-pane window. But what you really want to dig down to is ask yourself, how do you use energy or heat away from your home? So in your home, if the kids are cold or such, you just go over and you just turn a thermostat, and it's going to go ahead and send a control message down to your basement, most likely, or crawl space, to tell the furnace what to do as far as kicking on and off. And you're not even involved in that process. And when we get into smart grid technology and those type of thermostats, thermostats can quote-unquote even learn, if you would, what our behaviors and habits are for certain rooms or portions of the house. Now, all of that depends on, again, having an electrical system for the most part. Although the old thermostats, the mercury trip thermostats, you're able to get away without it, though for the furnace itself, of course, you would need to have some type of electricity. So the best thing that you can do is at your cabin, next time you go out, go ahead and list all the items that you use for some type of heating. Estimate how many hours in an average day, maybe you go for the summer or such, just pick an average day, how many hours do you use heat? And then figure out generally how much each device really needs to operate. So you might have, again, a stove for heating food, and you might be able to figure out a way in which you can consolidate meals. You might go ahead and obviously have space heating, and you might, as we see later, go ahead and create your cabin in such a way that you have a thermal mass that can absorb some of the heat during the day, and then simply passively, without any type of electrical assistance, put the heat out at night. Not too much dissimilar when we build large stone fireplaces that will hold the heat during the fire and then let it out slowly over time when the fire's out. From the old colonial days when people used to go ahead and they didn't have electric blankets, so to speak, so they would take a pan on the end of a long stick and put hot rocks in there. And the rocks will have been in the fireplace for much of the time, absorbing the heat much like a battery absorbs electrons. And then they put it in the pan and then put it under the bed, so to speak, kind of a manual electric blanket, if you would, or heat blanket. So let's take a look at how we want to maybe go about and think through creatively some ways of heat. Now here's someone who I work with who is out in a village, and this is kind of, okay, so I'm somewhat tongue-in-cheek here. This is not a off-the-shelf factory appliance, obviously, but this might be a good reason why you should look at investing in one. And we'll look at one in a minute on propane. It's a hot water heater. This is a homemade jimmy-rigged hot water heater. Someone is creatively taking a Coleman stove fuel bottle and has hooked it up in such a way that it can beef out a flame. And then they've taken an old Shout laundry bucket of 5 gallons, and they've got a hose coming in, bringing in cold water, and then a hose that's traveling onto this little homemade burner that they've made with a small propane torch or camping bottle, and then it takes it out probably to a shower or to a sink. Now we see to the left, you even have a washing machine. Of course, this is a situation where the people would need to have, again, a 110 plug-in of some kind. My point being, even though you can make something like this work, there are some sophistications, and there's always a danger of fire. So here, this was actually used for a shower, for a hot shower. And as you can see, it says, start your water flow, literally. Light the burner, turn a quarter, then to full, and then it tells you how to stop it. And it says keep the shower curtain away from the burner. I think they mean burner there. But the point is well taken that with a homemade device, you can get by at a cabin, but there, as you kind of increase your amenities, your shower, and try to live more like the home life, you might either overburden or put in a dangerous situation some of these appliances or elements that you've made. Now, one of the fuels that's often used in cabins, as I mentioned before, is propane. You can get a 5-gallon tank, something similar to what you put on your barbecue grill. These are much larger, and you'll notice that they have caps on the top. Tin caps, so to speak, to protect that valve that I mentioned earlier. If you drop a tank real hard on that valve, it can actually propel the tank like a missile. Here, these have that safety cap, and as you can see, there's a wire going from each one. That's not an electrical wire. That most likely is a cable to lock up and make sure nobody can take the tanks. So here they have 4 in a row, ready to go, on the back side of a cabin. And they probably use one up, then obviously go to the next. So here's some devices that you could use. You have a propane oven and stove. Believe it or not, I have seen people heat their cabins with an oven. They'll go ahead and they'll have the oven turn on, open up the door, and usually just to take the edge off as far as if it's cold. They'll use a propane oven similar to this, and then the top, the burners are all propane. These, by the way, are not easy to find. They're actually in somewhat high demand. And then there's the propane on-demand hot water heater. Now this is interesting because some of the newer versions, you don't even have to have a pilot light. You have kind of a ignition. This does not plug into electricity, but you turn that, I believe it's the gray knob, and it will start a spark, and you have some propane on hand, and you can heat 2.5 gallons at a time as you need it. Instead of in your home where electrically you plug in and have a 60-gallon tank. It's just full of water on demand that you probably won't use but once or twice a day, depending on how much you wash clothes and shower. Now, the other thing that I should say is that regardless whether you charge it with a solar panel, whether you charge it with a generator, a diesel generator, or how you plow electrons onto it, a lot of people will get batteries and battery banks built up so that they can go ahead then and extract electricity off of it at another time and then use maybe an electric heater of some kind. So in general, here I have a PV solar panel. That is a solar panel that has electric leads on the back which gathers electricity. And once it does, it's going to plow that electricity onto a battery, and then on the battery you can go ahead and later on take heat off for your electric heaters and such. The thing that I always tell people to keep in mind is that charge controller, that box to the lower left, is everything. Everything. You want that charge controller to be adequate and accurate and set for the amount of batteries you have. The batteries, such as I showed just recently, are $250 batteries a piece. They're often for marine use. They're deep cycle. So right here we have basically $1,000 worth of battery. Well, if I don't have a charge controller and properly regulate and pack in how I use those electronics off the solar panel, or it could be a windmill, or it could be a little water turbine, doesn't matter. Whatever can send electrons across and through a line. If I don't have a good charge controller, it could be that I'm only using a certain percentage of my batteries. I'm not really packing them out. That will decrease the life of the battery, and also it's expensive as they are. It takes away from the ability to really get the most bang for your buck when you're using your panel or your windmill or such as that. So on the other hand, you may also be pulling electricity off the battery so that you can plug a regular 110 wall device in and heat your house. And here in this picture, I've got a pellet stove. Now you'd think, well, pellets, don't they just fall into the stove? Why is there any electronics? Actually, pellet stoves have a good amount of circuitry to them. And therefore, you wouldn't want to just basically put jumper cables on your 12-volt battery and then take the negative and the positive and kind of clip them on, if you would, to the 110 plug of the pellet stove. You instead, in the middle, want a pure sine inverter. Pure sine inverter. And that helps to take care of the transfer of electricity where you can use it for heat. If you try to run one of these pellet stoves such as this without electricity, it's not going to fly, even though you have fresh fuel going in there by an auger or a gravity feed system. So let's just talk for a moment. Are there any questions so far? I'm sorry. Okay, well, we'll move on. So the thing that I want to just mention is if you are going to go with batteries to go ahead and store electrons that you could then plug in a 110 volt type of heater lately and get heat that way, you just want to be sure of a couple of things. Don't stick the turbine just simply on the top of your house, but rather bolt it to the side of your house and then use guy wires coming out to kind of secure it from all angles all the way around. In addition, if you're going to put solar panels on, and the kind on the left actually hold a fluid, they're thermal solar panels that then goes ahead and circulates fluid through the face of the panel, heats it up and moves it through to get more fluid. Or whether it's like the ones on the right where you have rays coming in and it converts the rays to electrons, which you get by having a negative and a positive lead off of the panels, back to the panels. Regardless, mount your panels at 90 degrees. Otherwise, you're going to have this problem that you see on the right where the screen is totally covered up just from mere snow accumulation, or on the left, it starts to pile up if it's not clinging like on the right. It starts to pile up and create a big problem. And then finally, don't just, if you got a creek nearby or you're down by the river, don't go and merely buy the first turbine you see. what you have here is you have one that's designed on your left specifically for fast running rivers with very low volume. And on the right, big, broad rivers with a lot of volume, but very little waterfalls or constrictors that you can kind of power or push through the veracity and the velocity of the water. So the one on the left would be more like in southeast at a small maybe creek or something that's got waterfalls, and the one on the right would be for the very broad rivers like the Yukon and the Thames. Now I want to show you how all of these are actually available to a cabin owner if you were to create a cart such as Danny Lana has done. He's originally from Nome, and with some students here in Fairbanks, he uses this old construction cart. Inside that construction cart there used to be a diesel generator. That's been plucked out. And up on the mast there, where the wind turbine is, the three-bladed yellow and blue wind turbine, that used to be, in fact, a stadium light. And contractors will pull these behind their trucks with a 2-inch ball hitch, and then they'll go ahead and get out. They'll start it up, and they'll take and raise the mast and shine a light on their project, especially when it gets to be in the fall and they're short on contract and they need all the time they can get. In this particular case, however, he's replaced Dana's with a windmill, and on the side panels, he intends to put solar panels as well as a wire, a very thick wire coming out of the front attached to a windmill, or I mean a little hydro water wheel, wall propeller, such as the one on your right-hand side in blue. So this unit, the nice thing about it is that whether it's wind, solar, or water, it's plowing electricity onto this battery bank that's inside that unit. Now, the other way that you can use heat is you can go ahead, and in the bush there are quite a few satellite dishes that some of them have bullet holes and such, but by and large aren't used anymore to gain signal from cable companies or whoever had used it before. Therefore, in the recycling arena, you can take an old one of these dishes, they come in pie pieces as you can see, and bolt them together to each other side to side. And you can put a large aperture of 4 rods out, and in the middle you can put something that's going to need to withstand heat, because what's going to happen is in lining the middle or the inside of this dish with mylar, which is a shiny reflective type of material that has adhesive on one side. You pull back the paper and it has adhesive. You can take one of these old solar dishes and very evenly go ahead and apply rolls of mylar so that the sun bounces off it. And what the gentleman there, Phil Hewitt, the inventor, is holding is the backside of a washing machine where he has a bunch of ribbed yellow holes made out of metal that's designed for the pressurization and different anomalies in the gas line industry. So basically, in this case, he's making a system that will concentrate all of the sun's rays on that one kind of little stainless steel plate he has, which is the backside of a washing machine basin. And then he wraps it with the hose that I mentioned. That then goes, if you'll look down by his knees, across, and there you are. There's a picture there from the kind of the inside of the dish looking out. He'll put it in sand and gravel underneath his home. Now, you couldn't do this where you had a cabin on permafrost, granted, But if you have a permafrost-free cabin, what you can do is go ahead and put fin tubing down there, pack it with sand, put more fin tubing, radiator tubing, pack it with sand, and then basically go ahead and touch or run that hose in that has the hot fluid, 1500 degrees, and run it through the pipes. And the pipes with those little fins will suck or pull the BTUs out of the fluid and then just sit on it and store it. And then overnight it'll release some of that, let it go, and allow for there to be heat in the house. The gentleman who worked with this, he said to me that in April he just did a little anecdotal kind of test and said that he was going through 2 gallons a night fuel oil. He went to this and he went through about a quart, so about 1/8 of the fuel needed under those somewhat simplistic conditions. So this is one way of using the earth is heat storage, and what happens at night is the sun's not shining, so as the house cools down, then the design is such that the heat will come off of this big mound of dirt and sand that's over these tubes or copper pipings, and it will heat up the space heat. The one problem is you need a circulation pump for about a 0.5 kilowatt day, and that will run you probably by Fairbanks standards about 12 cents a day. Just that one aspect and piece, and that is the circulating pump to keep things flowing. Any questions so far? Well, something that's been popular in this area is not using the sun or propane rather so much for heat. It's just using some of the scrub brush that we have around, or maybe even tree limbs. And rocket stoves are a type of unit that allows you to horizontally feed the feedstock, so it just concentrates on the tip rather than a whole log on the fire, so to speak. And it also allows you, in addition to having that horizontal wood product or grass product, it allows you to go ahead and use much less wood for the same BTUs. And they've been very popular in Alaska, these rocket stoves. So here's a stove that's kind of creative that I wanted to show you, where someone took a piece of pipeline. You know, that's probably like, I don't know, a 12-inch pipeline. They cut the ends off. And then they thought, you know, I'm going to put a door, much like the barrel stove that I described before, on the end of it, put some feet on it, and then go ahead and also have a cooktop. And so this is very crude, but you could stick a good 2-foot size log in there, let it burn and simmer and heat up that top plate, something that you can cook eggs on in a skittle, and will heat up the house at the same time. Now there's also the option, again, assuming that you're off-grid and you don't have electricity, of hauling in wood pellets. Now for this stove you would need wood pellets. You just couldn't take chunks of wood that you found outside or grasses. But you know, a couple bags of pellets on the back are kind of limp, and on the back of a snow machine, a four-wheeler, it's certainly doable. In this case, at the very top by the silver stainless exhaust pipe, you would find in the back a bin that you open up, pour pellets into, and as long as you keep that bin full, and I'm told it'll last about 1 day, because this burns about a little more than a gallon an hour, you know, you need to keep it going. You need to keep the feedstock in there. But, you know, for a cabin, this just may be ideal. It's not difficult to transport. It's good thick gauge metal. However, you can put wheels on the front, believe it or not, and attach a little handle. The wheels are $100, and you can move it around. Now, this is one item, as are some of the couple next that I'll be showing you, that is not an invention, but it's simply a proprietary design. You can buy it off the shelf. This is a Kelly kettle, and if you're at your cabin, you may end up using this in your house. The only problem is that, again, when you cook in your house and you don't exhaust the fumes out, you're going to end up with basically some difficulties of different types of gases, such that your air quality is poor, and then you have respiratory problems. In this one, you fill this little bucket on the bottom and you light it up, and then the tube-like, as you can see to the far left, structure actually has a water jacket that you pour water into, and the fire goes up through the middle tube, and you can actually buy a little type of, for $6, I think $7, kind of X type of tray that fits on the top of this, and you can actually cook off it. Again, you know, it's not a whole lot of burning that you're doing. You probably could get away with this in the cabin if you wanted to cook, obviously, food. Maybe go ahead and heat up water. But I always encourage people to somehow vent their stoves outside. And you may actually be able to fit a small stovepipe, diameter stovepipe, over the top of this Kelly kettle, so to speak. I've got one here, and it looks like it's probably a 1.5-inch fitting, if you could find a way. But the other thing that I would mention is that this is a biomass stove that has this orange box on the side. And I want to bring this up because what happens is you feed horizontally, like most rocket stoves, your fuel stock. You light it, and the gases waft on up, and you get a drawing of air by the heating of air at the bottom of this device and the air rising. However, this has a little orange box with an electrothermal plate. It has a plate that, albeit is not very efficient, but it converts the heat from the side of the stove into electrons that then power a tiny fan, which then increase and exacerbate the burn, similar to bellows in a blacksmith shop. And there's a little port for your USB port for your devices to charge them, believe it or not. Lastly, there is a device that you could use if you wanted to heat again with electric in your house, where you can put wood chunks and biomass outside of the home in this unit. It sticks outside of the cabin or home, and you go ahead and burn hot and hard different wood scraps, and the lower cylinder then turns it into gas, which in effect will power a Chevy engine, an alternator, and you can actually plug into this like a diesel generator. So those are some devices and some thoughts as you think about fuels as well as devices in trying to create home or heat for your cabin, for either the space heat, for the water, or for cooking. I want to thank you for joining this discussion, and if you have any questions, feel free to contact me again at alnashjr@alaska.edu or 474-6366. Thanks again, and keep that cabin warm.